This is the review for the test over rigid motion transformations. Question 1 says to complete the translation given the function. There's going to be 2 test questions about this. So here we read this as capital T for translate the triangle in the distance and direction of L to M to get triangle prime. Okay, so translate basically means to slide. So we want to slide this triangle the distance of L to M and the direction of L to M. And so it's going to end up somewhere over here. Now the way to do that, and I'll be using line segments here and copying and pasting, but on your exam, you'll be using a ruler. But the process, the idea remains the same, right? You want to measure this distance from L to M, which I have done by making a line segment, this red line segment. And then you want to take this line segment and place it, what did I just do here? Okay. And place it on every point of this triangle so that we can essentially slide all the points that distance and direction of L to M. Okay, notice how these red lines are parallel to that original line LM. Okay, they're all going the same direction, that same angle. And now we've essentially slid all these points to the ends of these line segments. And if we connect those, we get our new shape. All right, so let me zoom in a little bit here. So I connect here, here, and here. And now you can see that new triangle that we've created. Similar to exactly the same as our original triangle, just slid down the distance and direction of LM. Okay. So like I said, in order to create these lines, you'll be using a ruler. You'll use a ruler to measure L to M, and then you'll do your best to make these lines parallel to this line here. Okay, so question 2 asks to write a function to describe the translation. The solid figure is the pre-image, and the dashed figure is the image. Pre means before, so this solid figure comes first, and this dashed figure comes second. And so when we write the translation function, we're going to do capital T for translate. And because we're going from here to here, that's S to T. Okay, so we're going to put subscript ST. If it was going from the dashed figure to the solid figure, it'd be TS, but that's not what we have here. Okay, and so this is basically saying we're translating something the distance and direction of ST. What are we translating? Well, we're translating a trapezoid. Okay, and what do we get when we translate the trapezoid the distance and direction of ST? Well, we get a new trapezoid, or in other words, we get trapezoid prime, right? The apostrophe up at the top means new, okay? And that's the prime. So if we translate the trapezoid the distance and direction of ST, we get the new trapezoid, trapezoid prime. Okay. Question 3 asks us to complete each reflection given the function. There'll be 2 test questions about this. They want us to reflect LMNO, so this shape here, over the line J, which is, as you can see, diagonally placed. Now, whenever you have a line here that's diagonally placed, you want to be careful that when you're measuring the distance from M to J, which is what you want to do, because in order to find M prime, it's going to be that same distance, just on the opposite side, that when you're measuring that distance, you're measuring along lines that are going to intersect J at 90-degree angles, so that they're perpendicular. Okay, and the easy way to do that is using a protractor, which here I'm not going to do that because Kami doesn't let you draw along this edge. But when you're doing this on your paper, you can use a protractor and line up this vertical line here, the 90-degree line, with that J line, and then you can draw guidelines along this edge that will hit J at 90-degree angles. Like I said, Kami doesn't let me do that, but you can do that using a protractor. on a pencil and paper. Here, I'm just going to sort of guesstimate that 90-degree angle. So here, notice, I don't want to go here, right? I'm not trying to cross like that. I'm not trying to cross like this. I want to cross so that when I hit this line, right, they intersect at 90-degree angles. That's going to be right about there. Okay, and so now if you were to get a protractor and you were to try and measure this, you should see that it's about 90 degrees, which it is. If you were to rotate this line, you'd get 90 degrees over here. And that's what we're trying to achieve, right? You want to fit the corner of a box right there. Okay. And so now that I have that, I'm going to continue drawing lines for the rest of my points. Trying my best to make them perpendicular. Let me zoom in a little bit. Okay, and now that I got all those lines, I'm going to copy and paste them so I can go the same distance on the other side. And you can use a ruler for this. You can also use a sheet of paper to mark down your distances. For me, I can copy and paste because I'm doing this on Kami. And as you can see, I'm going the same distance on the other side of the line here. All right, so now that I've done that, I've essentially reflected each point individually, and now I can connect those points to get my reflected shape. So I'm going to use purple here. And I actually wanted the line tool. So you just have to remake the shape over there on the other side over here. And they should look roughly the same. All right, so as you can see, the purple figure here is a reflection of LMNO. In other words, it looks like it flipped over this line or is the mirror image of LMNO over this line. Okay, so continuing on. Question D asks us to write a function and describe the reflection. Okay, so as you can see, JKLMN is a reflection over line O that gets us J prime, K prime, L prime, N prime, N prime. So in order to write the reflection function for this, we're going to use capital R for reflect. And then for our subscript, the line of reflection is O, so our subscript is going to be O. Okay, and then we took JKLMN as our input, and so this is saying we reflected JKLMN over O, and the result of that was the new shape J prime, K prime, L prime, N prime, N prime. So fairly simple. All right, question E asks us to complete the rotation given the function. So this says rotate MNOP about point A, negative 40 degrees. So we need to keep our positive and negative rotations in mind when we're doing this. Okay, so for example, a positive rotation is going to be counterclockwise, and a negative rotation is going to be clockwise. So counterclockwise, clockwise. positive, negative. So here it's saying to rotate negative 40 degrees. This is the center of rotation, so we're going to be rotating in this direction. Okay, about A. And so the way to do this, and you'll use a ruler, but of course I have line segments here, so I'm just going to use line segments. I'm going to draw a line segment from A, the center of rotation, to one of the points that I want to begin rotating. And here I want to rotate M. Now once I have that line segment, I can get the protractor and I can line it up with that line segment that I drew as my 0 degree line and line it up with the center of rotation at my center and with that line on my 0 degree line, which in this case will be right there. And then I'm going to mark off 40 degrees. Should be right there. Okay. Now once I have that, I draw a line, well, straighter line than that. I draw a line from A to that point there. And then I want to measure the distance from A to M because A to M prime is going to be that same distance from the center of rotation. And so here you would use a ruler. Of course, it's a little bit difficult for me since I'm on Kami. But that's okay. We'll just do our best here. So right there you see that that's about 3.5 centimeters. Right, so we want to go 3.5 centimeters. Should be right there. And we want to mark down our point, M prime. Right, so right there we have M prime. So good, I've rotated M negative 40 degrees to get M prime. Now I'm going to do that same thing for all the other points. I'm going to do the exact same process. And I'm going to try and go do this a little quicker. So I'm going to draw a line segment to P. I'm going to grab my protractor. I'm going to set it up in the appropriate orientation. I'm going to mark off 40 degrees. I'm going to draw a line to that from my center of rotation. Notice how all my lines are going back to the center of rotation. You should have no lines that are going from, say, M to N. Okay, that wouldn't make any sense. Or M to over here. Okay, so now I want to measure the distance from A to P. As we can see, it's going to be about, it's a little under 5 centimeters. Let's go ahead and measure out 5 centimeters, a little less than 5 centimeters. It's about right there. I don't think I drew my red line far enough, but that's okay. You can kind of see where that point is anyways. So it should be right about there. Okay. Draw my line segment to O. Grab my protractor. Mark off 40 degrees. Draw a line to that mark I made. Grab my ruler. So that's a little under 5 centimeters as well. Okay, so it's going to be right about here. Okay, and then lastly, we're going to grab N. Three and a half. So I'm going to measure out 3.5. Okay, this is very difficult. Okay. Okay, so 3.5 is about right around where M is. So we're just going to mark it where M is. There, that's N prime. Okay, so now we've rotated all our points. All we have to do is connect them. And done. We've rotated MNOP negative 40 degrees about point A. So you see it's going in the clockwise direction. All right, so now let's go to number 6. So number 6 wants us to determine the center of rotation and write the rotation function. So in order to do that, there's a few steps that we can follow here. So I'm going to list those out for you here. Step 1 is to draw the perpendicular bisectors for two sets of two corresponding points. So what do I mean by that? Well, two corresponding points would be like C and C prime or A and A prime. Okay, so here I want to draw a line segment between C and C prime. And I want to find the perpendicular bisector for that line segment. Now to find the perpendicular bisector, and we've done this before, you use a compass. Okay, and you set it to a pretty good distance. You don't want to be less than halfway of this line segment. You want to be greater than that. And so a good rule of thumb is just to, maybe go the distance of the line segment or longer. Okay, so I'm going to go about right there. And I'm going to go ahead and make my lines based off of that. I'll make them in green. So here I'm drawing my arc there, and that might not be very long, so I'll put it there. So you see how I drew my arc covering this entire distance if you're looking out from this side of the line, right? Because I expect my perpendicular bisector to intersect somewhere in that area. So I'm going to draw an arc there. Then I'm going to keep going. I'm going to draw an arc on the other side, and I should have did this for the other one as well. But it's okay, we'll just go back and redo that. Okay, and I will be providing you physical protractors to do the same thing. And so just keep in mind where I'm placing this. You see the point is at the ends of the line segments. And I can get 2 arcs from there. And then I get 4 arcs in total. And where those arcs intersect, I'm going to connect them with a line. Okay, so I'm going to make that line purple. And right there's my line. Okay, so that's one perpendicular bisector for one set of 2 corresponding points. Now I need to do it for another set of 2 corresponding points, right? We need 2 sets. And so another set of 2 corresponding points would be A and A prime. So those are the ones I'm going to pick. We'll begin by drawing a line from A to A prime. and I'm going to make the perpendicular bisectors to that line. So like I said, place your compass so that the point is on one end of that line segment, and I'm going to make these orange. And watch how I can make a full circle. Okay, so it doesn't really matter. Okay, I'm going to show you that you can do a full circle and you're still going to get the same answer. All right, so I'm going to do a full circle. Place it on the other side, do another full circle. Okay, right here, that's where the arcs intersect. Right here, that's where the arcs intersect. I did full circles. I still got the same thing. Okay, so that's fine. You can do that. Just connect those intersections at the end of this. And done, right? We've drawn two perpendicular bisectors for two sets of two corresponding points. Now, step 2. Step 2, and this is more of a statement, is that at the intersection of the perpendicular bisectors is the center of rotation. So right here where this purple bisector meets this purple bisector, that is the center of rotation. Okay, so I'm going to go ahead and label that with a point. Bang. And here it says the center of rotation is at point X, so I'm going to label that X. Okay, and so that answers the first part of our question, which was to determine the center of rotation. And now we're going to go on to the second part of the question, which was to write the rotation function. So now that we have the center, we can start thinking about our rotation function and what we need to complete it. So we're going to use capital R for rotation. And because our center of rotation is at point X, we're going to use subscript X. And now the second term in the subscript of the rotation function is the angle of rotation. And so that's going to lead us to our third step here, which is step 3, measure the angle of rotation between two corresponding points. So let's use A and A prime, for instance, two corresponding points. In order to measure the angle between A and A prime, or in other words, the angle in which A was rotated to become A prime, we're going to make a line segment from the center of rotation to A and another line segment from the center of rotation to A prime, and then measure the distance between that. So here I'm going to use baby blue, and I'm going to draw a line from A to the center of rotation, and then a line from A prime to the center of rotation. I know there's a lot of lines here, bear with me. And so, and I'm actually going to make this line to A a little bit longer, and you'll see why I did that in just a moment. So when I grab my protractor and I come over here and I place it at the center of rotation, I line up one of my lines that I drew, the baby blue lines, with the 0 degree mark, which in this case would just be the edge of my protractor right there. And now I can see where the other line to A prime has been rotated. Okay, so this is at 0 degrees, and this has been rotated up until about, oh, what is that, 65 degrees. Okay, so here I'm going to put 65. Okay, but we've got to be careful because ABC was rotated about X in this direction. And if you remember, something rotated in this direction, and we can come up here for reference, is negative. See, that's not positive 65, that's a negative 65. Okay. And now, what did we rotate? Well, we rotated ABC. Okay. And what was the result of rotating ABC about point X, negative 65 degrees? Well, it was A prime, B prime, C prime. And there's our rotation function. Okay, so, with all the lines and everything, it looks fairly difficult, but, it's a very step-by-step procedure, and a lot of them are repeated. So, kind of study that and think about it a little bit. And we'll also do another example over here on number 7. Okay, and this one I'm going to work through a little bit quicker, but just to give you another example. So I'm going to pick 2 points here. I'll pick S and S prime. And I'll pick Q and Q prime. And I want to make the perpendicular bisectors to those. In this case, I'm just going to draw a full circle. But again, you really only need to draw the arcs up here and then down here. But I'm going to draw a full circle just to illustrate that you can do that. Okay, but not that big of a full circle. Okay, so right there I've drawn a full circle. Then I'm going to go to the other side, and I'm going to draw another full circle, because why not? See, I only really needed these portions of the circle, where the arcs intersect. But in either case, I got the intersections. And now I'm going to connect those with a line. And then I'm going to do it for the other line segment. All right, so this line segment connecting Q and Q prime, I'm going to do it over there. And again, I'm just going to go ahead and draw the full circles. Right there and right there. There's the intersection. You see, I kind of cut off the circle here, but it didn't matter because I can still see the intersection. So you don't really need to do the full circles. You can just do arcs. I think full circles are a little bit more messy anyways, but here I have colors, so it doesn't really matter. But here I'm going to connect the intersection of these orange circles. And right there we see where our center of rotation actually is. Now I'm going to go ahead and fix this line a little bit so that we can clearly see where that center of rotation is. And I'm going to go ahead and mark it. Here it says the center of rotation is at point X. So again, we're going to label this X. And now I want to measure the angle of rotation. So I'm going to go ahead and draw 2 lines to 2 corresponding points. So here I'm going to do P and P prime. And for this, let's just go ahead and use black. So I'll draw one at P, and I'm going to draw another one at P prime. And then I'm going to measure the angle between that using the protractor. Place it at the center. Line up my 0-degree edge or tick mark with that. And then see where it's being rotated to when P becomes P prime. Well, it's being rotated to about 65 degrees, which is purely a coincidence. So let's go ahead and start writing that function. So it's going to be capital R for rotate. X was our center of rotation. As we said, we rotated 65 degrees. And if you can see, PQRS was rotated this way. And so that's counterclockwise. And so again, this is negative I mean, that's clockwise, not counterclockwise. And then what did we rotate? Well, we rotated PQRS. And what did it become when we rotated it? Well, it became P prime, Q prime, R prime, S prime. And there's our rotation function. Okay, so not bad at all, not really too difficult to come up with. All right, so question 8. Question 8 wants us to write congruency statements for the corresponding sides of the following figure. They are reflections of each other across line N. Okay, so if two things are reflections of each other, they are congruent. Okay, that's part of what makes a reflection a rigid motion transformation, is that the shape remains rigid when you're performing the transformation. In other words, it stays the same shape. Okay, that's why we also call it an isometry, because isometry, iso means same. Metry you can think as being short for geometry, so same geometry. When you translate, rotate, reflect something, it maintains its same geometry. And so if, say, this line AB is a reflection of XZ, we can say that those two are congruent because they're reflections of each other. So here we can say, and I need to find my proper notation for this. Here we go, right here. AB, and notice I put the little bar on top so that we're aware that this is a line segment, is congruent to XZ. Okay, and then let's do that again, but for another side. So AC is a reflection of YZ, so we can say that those two are reflections of each other. So AC, and I actually used the wrong symbol here. I should have used the congruent symbol. So let's go back and change that in just a second. And AC is the reflection of YZ, and so those two are congruent to each other. And over here, I need to fix this. Okay. All right, so AC is a reflection of YZ, so those are congruent. And lastly, BC is a reflection of XY, so those two are also congruent. So we're going to say BC is congruent to XY. And there, we're done. So yeah, I mean, I hope all that was helpful, and good luck on the test.